First thing is that you will get both of the things. You will get recorded lectures and extra classes. Both of these you are going to get for solutions. Okay. Now, as of now, we have not done haloalkane, haloarine. So for haloalkane and haloarine, you will get previous year's recorded lectures. Okay. You'll get previous year recorded lectures, and then similarly, you will also get extra classes for this.
Okay, so.
And I can perfectly assume that you have joined at this particular time because test nazdik, right, Madiha?
So I was searching for like a coaching from a long time. So I
For a
will.
long time. Okay.
Yeah, like our classes started more than a month ago. So I was searching since then.
So you have tried a few, or you were not able to try also?
So what?
Did you try a few? I mean, coaching
Yes, sir.
tuition. So
I
you
have
tried
so.
all.
I have
Okay,
so.
15. So see, you have test, Hannah. So my priority will be that you score good in this, in like the upcoming test that you have on 30th. So do electrochemistry with us, and then you will get recorded lectures and also extra classes. Just message me on this number, and I will send you the recorded lectures of solutions chapter and also for haloalkane, haloarine. Same thing is also for Chavez. Okay, Chavez, you also please message me. Na, आपने message नहीं किया था. We had our first class. ना, आपने message नहीं किया था लेकिन.
Right.
Now, in electrochemistry, we are currently at electrode potentials. Okay. In the last lecture, we started with electrochemistry and we are at electrode potential. Okay. Let me see what is things that we have already done. Okay, fine. So we have written for oxidation potential and reduction potential. Now, please see. Let me give you a bit of introduction. What is oxidation potential and what is reduction potential? Okay. So, for example, if you have potassium, and potassium has a tendency to lose electron, it will form potassium positive, and it will give out an electron. Now, this process it can be spontaneous and it can be non-spontaneous, both the things. If it is spontaneous, then we can use this process in order to extract some electricity. And since potassium it is a metal, this process is what it is, spontaneous. And it is getting what, oxidized. Potassium is in zero state and it is getting.
Your voice is lagging.
My voice is lagging.
Yes, sir. It's my internet.
Just a second. What about now?
Sven.
Is it fine?
Yes.
Guys, tell me, is it fine now?
Yes, sir.
Yeah. Okay, fine. Yeah. Since potassium it is a metal, it is going to easily donate electron and it is going to easily lose electron. So this process is spontaneous. And since it is getting oxidized, potassium has an oxidation state of 0 here, and it has a positive oxidation state. That means the oxidation state is increasing from 0 to +1. In that case, we say that the oxidation potential of this particular reaction is positive, and in terms of number, it is equal to plus 2.93 volts. Okay, so this is oxidation reaction and its potential, oxidation potential. If I just do the reverse, if I have K positive and I add an electron to K positive in order to get potassium metal. Now, obviously, the previous process, it was oxidation and it was a spontaneous. And if you are reversing the reaction, then obviously it is going to be a non-spontaneous reaction. And if it is a non-spontaneous reaction, then we have to give some electricity. And when we are going to give electricity, for example, if I write reduction potential, then this will be equal to negative of 2.93. Okay, so this relationship, please remember this relationship, that for a particular redox couple, redox couple का मतलब क्या होता है? For example, K and K positive, these are couple, है ना? That means reduction is going to give from K positive to K, and oxidation of K is going to give you K positive. So it is known as what? Redox couple. So for a particular redox couple, we can say that reduction potential or oxidation potential is equal to the negative of reduction potential. Whatever be the value of reduction potential, उसमें आप negative multiply कर दीजिए, you will get the oxidation potential, as you can see this case. Negative 2.93 into negative or into -1 will be equal to positive 2.92. You just need to change the signs. Please write this down. After you are done writing this, please write, given the standard electrode potential, determine the oxidation potential for each.
Sir, can
Yeah,
you
standard. Yeah, tell me, Chavez.
explain once again what is oxidation potential?
Oxidation potential, it is the electricity that we can extract from a spontaneous reaction. Okay, and when the reaction is an oxidation reaction, so that potential is known as oxidation potential. How much amount of electricity you can extract from that particular reaction. Okay, or how much electricity is needed. Agar negative hai, तो it is needed. If it is positive, then that much electricity we are extracting from the reaction.
Okay, sir.
Got it? So qualitatively
Yes.
speaking, is the tendency of a particular element to get oxidized. That is oxidation potential. Tendency to get reduced is given by reduction potential. Now, there's one more thing, please see before writing this question. Given the standard electrode potential, when I talk about standard electrode potential, this is the standard reduction potential. Okay, as you can see, K positive to K, this is the reaction happening. Ag positive to Ag, again reduction. Hg2 positive to Hg, again reduction. Mg2 positive to Mg, again reduction. Cr3 positive to Cr, again reduction. So whenever they say standard electrode potential, it means standard reduction potential. Okay, standard electrode potential means standard reduction potential, or I can write SRP. Okay, so I hope this is very easy for you guys. ठीक है, देखिए. Let me get the first one for you. Please see here, guys. Keep your pen aside. Now, K positive to K, this is what? This is reduction. And it is having what is the potential is minus 2.93. So if I reverse this, I will get oxidation. K to K positive, this is oxidation. And it is going to have how much potential it is going to have? Plus 2.93 volt. Is this understood? Yes or no? Please tell me, guys.
Yes, sir.
है ना? Similarly, Ag positive to Ag है, तो इसको कैसे लिखेंगे? I will write this as Ag to Ag positive. This will be equal to minus 0.80 volts. Similarly, do for the rest of them. Send your answer on my WhatsApp 7530 998 007. And those who gave the test on last Friday, did you get the marks? Hiram, Fahad ne to nahi diya tha. Tarif gave the exam. Rabia gave the exam. Faiza, you also gave? Faiza, आपने दिया था?
Yes, sir.
मार्क्स मिले आपको?
No, sir.
अच्छा नहीं मिला अभी तक आपको, ठीक है, मिल जाएगा. Faiza, I think I don't have your number. Otherwise, I will send it to you right now. Faiza, no, I don't have your number. Yes, but that is correct. If it is a non-metal, then generally speaking, it is going to have a positive reduction potential. But as you can see, for some of the metals also, in this case, we have Hg. It is having a positive reduction potential. And so we will see how it is determined, and we'll also look at the series. Please send it fast, guys. I'm giving you 2 minutes. इतना time नहीं लगाइए, आप लोग बहुत ज़्यादा time लगाते हैं. In 2 minutes, please send me the answers. Okay, Pfizer. So for the next 3, the same procedure. Yeah, same procedure. And थोड़ा सा ट्राई कीजिएगा मधिया समझने की भी, है ना? In terms of what reaction is happening, oxidation हो रहा है, reduction हो रहा है ना, तो उसको समझिएगा कपल से. You have to look at the reaction in this order. K to K positive, तो oxidation हो रहा है ना? K positive ले दिया आपने, and then for Mg, correct, and Cr के लिए भी correct. Very good, Rabia. Right. Please see, guys. For the next one, yes. For the next one, Hg2 positive. I see. Actually, I was asking on WhatsApp because I want to see this couple also. What you are writing. अगर इसमें आप लोगों ने mistake किया, then it would have been of no use. अगर किसी ने Hg2 plus Hg लिख दिया, and if they are then writing minus 0.79 volts, then it is going to be wrong. ठीक है? Please understand that also. That you have to write oxidation. Hg2 positive. Sorry. Hg2 Hg2 positive. This will be minus 0.79 volts. Similarly, Mg to Mg2 positive, this will be equal to plus 2.37. You did not write for Hg, Rabia. अच्छा आपने Hg छोड़ ही दिया, क्वेश्चन में भी नहीं लिखा आपने. Mg2 positive. Then we have chromium to Cr3 positive. This will be equal to plus 0.74 volts. Is this clear, guys? Yes or no? Please tell me.
Yes, sir.
Okay. If you have any doubt, please let me know, or else please write the next topic, that is cell potential or EMF of the cell. Please write cell potential. Please write galvanic cell consists of galvanic cell consists of two half cells. Two half cells. First, right, we have the oxidation half cell and we have the reduction half cell. Okay, so please write half cell having higher value of reduction potential or standard electrode potential will act as so reduction potential jiska zyada hai, it is going to act as cathode, because what reaction happens at cathode? Reduction happens at cathode. So this will be your cathode. Second, half cell having higher value of oxidation potential will act as anode. नहीं, when I write value ना तो complete value, sign matter करेगा. ठीक है, sign is going to matter. Magnitude नहीं लिखा हमने, it is value, the complete value, positive negative दोनों को देखिएगा. Write this down. And then please don't write this thing. We will understand this concept using these values. Done, everyone? Yes or no? Please tell me.
Yes, sir.
Oh, great.
Yes, sir.
Okay. Madhya, can you choose one of these elements? Anyone?
So the last one.
Last one, Cr3 positive 3. So आपको SRP दिया हुआ ना, started electrode potential is what? It is the reduction potential. So SRP, what is given? First of all, we have Cr3 positive to Cr. Chavez, choose one of them. Anyone other than Cr3 positive to Cr? Yes, Chavez.
Yes, sir.
Choose any one of the elements other than Cr3 positive and Cr. Other than this, choose anyone.
Ag plus 2Ag.
Ag plus 2, okay.
0 - 0.80.
Ag plus 2 Ag, na? And it is going to have SRP of 0.80. ठीक है, SRP हो गया. हम सिर्फ समझाने के लिए लिख रहे हैं, please don't write these things. ठीक है. And then you have SOP also. SOP for this will be plus 0.74 and this will be minus 0.80. ठीक है. So you can choose कोई एक चीज भी आपके पास है. If you have either the SRPs or the SOPs, it is going to be fine. Now tell me, looking at the SRP से क्या पता चलेगा? What should be at cathode, right? What we'll know after looking at the SRP, what is the cathode? Now, in order to get the cathode, tell me which is having higher value. Which one will be cathode? Cr or Ag? Which one will be cathode? Tell me.
0.80.
है ना? Ag plus to Ag.
Yes.
And which one will be anode?
Ag to Ag.
Why Ag to Ag? SOP देखिए ना किसका ज्यादा है? Which is having higher SOP? Anode में oxidation happens ना? Please see what we have written here. Half cell
Yes.
having high value of oxidation. R लिख दिया हमने. My bad. OP. Oxidation potential will act as anode, which is having higher value of standard oxidation potential.
0.74.
है ना? Plus 0.7. This is the higher value. So what will be
Yes.
anode? Cr to Cr3
Cr.
because oxidation ना. ये तो reduction
Yes.
के लिए लिखा हुआ है. So we have oxidation. ठीक है. So we have got anode and we have also got the cathode. ठीक है. This one thing. Now what you need to do is anode Ag positive to Ag से हमको कितना एनर्जी मिल रहा है? I am getting plus 0.80. सही है. इसका रिडक्शन से कितना मिल रहा है? Plus 0.80. Cr to Cr3 positive I am getting plus 0.74. And when you are going to make a cell, तब इन दोनों एनर्जीज को ऐड कर दीजिए. How much you are going to get? 4 का 4, 8 15 का 5, and then 1.54. This is the standard EMF of the cell that you are going to get. Please write this down अब. समझ के लिखिएगा. If you don't understand, please ask me. Okay. See, guys, please try to answer when I am explaining things, है ना? Then only you will understand. I will take one more couple, है ना? And उसमें फिर आप बताइएगा answers. Okay, Madhya, please write this down as of now. Is everyone done? Yes or no? Please tell me.
Yes, sir.
देखिए जिन लोगों को भी समझ में नहीं आया, please try to answer this one. I'm taking two elements. I'm taking potassium and Ag. ठीक है? Now look at the standard electrode potential. यानी कि क्या दिया हुआ आपको? Tell me. Standard electrode potential means SRP or SOP. Oxidation potential or reduction potential? Oxidation. Very good. Standard reduction potential has been given. ठीक है? Now looking at these two, tell me which has higher SRP? किसका SRP ज्यादा है? Potassium or Ag? Which has higher SRP? Can all of you please tell me which has higher SRP?
AG, sir.
AG.
Higher SRP is for Ag. Now that means Ag will be what? Ag will be getting reduced, right? Because the reduction potential zyada hai. What does it mean? If I compare potassium and silver, which has the higher potential to get reduced? Silver. Now, if silver has the higher potential to get reduced, that means it is going to get reduced in comparison with potassium. Ag will be reduced and act as, बताइए, if it is getting reduced, then it will act as anode or cathode.
Cathode.
It will act as cathode. मदिया आपको समझ में आ रहा है नहीं आ रहा है? Yes, मदिया.
Yes, sir.
आ रहा है समझ में? ठीक.
Yes, sir.
Next, in this case, आप tell me now what do we have next? Potassium बचा. So potassium will be oxidized and act as एनोड. ठीक है, ये सारी चीजें ना लिखने की जरूरत नहीं है, आपके दिमाग में चलना चाहिए. ठीक है, यू डोंट हैव टू राइट दीज थिंग्स डाउन. आपको क्या होना चाहिए? दिमाग में चलना चाहिए. नाउ यू कैन मेक अ सेल. For those who have this as first class for electrochemistry, we first of all write the anode and then we write the cathode, and in the between anode and cathode we have the bridge. So the sequence is ABC. So in anode there will be K2, K positive. This is your anode. Bridge is given by two vertical lines, and in cathode what do we have? We have Ag. So Ag is in cathode and it will be reduced, so it will be Ag positive to Ag. Is this understood? Yes or no? Please tell me how to make a cell, how to determine anode, cathode, and then represent the cell. Yes or no? Please
Yes.
tell me.
Yes, sir.
Yes,
Yes,
What about this? Faiza, Rabia, Shaviz, आपको आया?
Yes.
Yes.
ठीक है, थोड़ा ध्यान दीजिएगा बस यहाँ पे. I am not writing K positive to K. If I write anode and K positive to K, then it will be wrong because यहाँ पे K positive to K, it is what it is getting reduced. So at anode oxidation happens, and at cathode what happens? Reduction happens. ठीक है. Now in this case, next thing that you have to determine is the E naught of cell. है ना, cell potential क्या होगा? So cell potential will be the potential of K to K positive is equal to how much? इसका उल्टा plus 2.93. And Ag positive से Ag का क्या होगा? 0.80. इन दोनों को ऐड कर दीजिए. 2.93 plus 0.80. This will be equal to how much? कितना हो जाएगा ये? 3.73.
3.7.
All of you understood this? Yes or no? Please tell me.
Yes, sir. Yes, sir.
इसको लिखिए. We will do one more. ठीक है ना, इसमें आप लोग चूज कीजिएगा. Try to think of a very tough pair. ठीक है, all of these pairs were easy. कोई tough चूज करने की कोशिश कीजिए. Wrote this down? Yes or no? Please tell me. All of you wrote this down?
Yes.
नहीं.
Yes, sir.
ठीक है. चलिए once again. Iram, tell me. Choose a pair. Iram.
Potassium and Mg2.
Potassium and Mg. What should be my first question? Tell me, guys. What should be our first question? अरे भाई, what should be our first question? अरे हम इतनी देर से क्या पूछे सबसे पहले? Yes, Faiza, tell me.
SRP.
हाँ, higher SRP. किसका है बताइए? Which has higher SRP, which is larger? 2.3
Magnesium.
minus
The magnesium.
magnesium is larger, right? Higher SRP किसका है? Magnesium. So magnesium will act as anode या cathode?
Cathode.
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 Very good, cathode. बचा क्या? What's remaining?
Potassium.
Potassium. Potassium will act as
Anode.
anode. ठीक है, अच्छा. Now when Mg is acting as cathode, then what will be its reduction potential? Mg2 plus 2Mg. यही होगा ना? This will be equal to how much? कितना हो जाएगा बताइए?
Minus 2.37.
Minus 2.37. For anode, we will write K to K positive, right? Because oxidation is happening at anode. This will be equal to how much?
Plus 2.93.
Plus 2.93. Sorry, not 3993. So what will be the answer for this? This is going to give you the E naught cell. कितना हो जाएगा E naught cell? Zero point. Yes,
Five,
Madiha, correct. Very good. 5.
0.56.
Okay, 0.56 volts. And how are you going to represent the cell? We are going to represent the cell. First of all, anode A, B, C. Okay, so for anode, we will have K to K positive. Then we'll have the bridge. For cathode, we are going to have Mg2 positive to Mg. Okay, so first of all, we're looking at SRP and determine cathode and anode. Then you can calculate E naught cell and then you can represent it. Say guys, all of you, yes or no, please tell me.
Yes, sir.
Yes, sir.
So there are few questions that I'm going to give और फिर आप लोग हमको तीनों चीज बताइए. You will represent the cell. कैसे represent करेंगे? ABC से. So you have to know what is anode and what is cathode. ठीक है? चलिए हम ये लिख देते हैं. So otherwise some people just determine anode and cathode. Represent the cell and calculate E naught cell. ठीक है? First pair is, let us take potassium and chromium. Second pair we are taking magnesium and chromium. Third pair ले लेते हैं Ag and Mg. ठीक है? इन तीनों के लिए करके बताइए. Send your answer on WhatsApp. ठीक है? I'm going to give you guys 5 minutes. आराम से कीजिए. And एक चीज हम आपको बताते हैं, ऐसा नहीं कि तीनों करने के बाद आप आंसर दीजिएगा. If you are done with the first one, please send the answer. If you are done with the second one, then send the answer. If you are done with the third one, then send the answer. ठीक है? अगर एक भी हो जाए तो प्लीज आंसर भेज दीजिएगा. Don't wait to do all of those three and then send the answer. एक एक करके भेजिए. Yes, Pfizer correct. EMF of the cell Pfizer, it is not right. Please calculate once again na, for potassium and chromium. Yeah, right now it is correct. Very good. Yes, Iram correct. Very good. Very good. 5 minutes is done, guys. एक ही आंसर आया अभी तक आप लोगों का. It takes some more time. Do the rest. Okay, Fahad. So Fahad, first one is not right. Second one में first one में आपको बता देते क्या सही नहीं है. The E naught cell is not right. EMF of the cell. Madhya, what happened? Add a +91.
Sir, I did, but it's not getting added.
Achha, do one thing. Write this number on some of your personal chats, ना जिसमें you can send the message on your own. आप खुद ब खुद को message कर सकते हैं and then click on it. You understood what to do?
Yes, sir. Let me just try one second.
Pfizer, this is for which one? MG के लिए है. MG and A. Okay, AG and MG. Okay, fine. Yeah, I think that is correct. E naught cell देखिए फहद आप. Your E naught cell is not right. Taviz, what about you? Tarif, what about you? Rabia, what about you?
Sound.
For the second one, Iram, Yes, correct. Very good. Correct. Yeah. Yes, right. Magnesium and chromium is fine. एक भी नहीं हुआ अभी तक आपसे शावेज एंड तारीफ. Not even one.
Once again explain this.
Once again explain this. बताइए what is the first thing that you need to do? Tell me. आप आंसर नहीं कीजिएगा तो कैसे चलेगा शावेज?
SRP.
हाँ बताइए किसका एसआरपी ज्यादा है, पोटेशियम और क्रोमियम? Tell me. Which is having higher SRP?
0
Yes,
minus
Shailesh.
0.74 watt. Chromium.
किसका है?
Chromium.
क्रोमियम और पोटेशियम.
Chromium is having higher SR.
क्रोमियम ना.
Yes, sir.
Okay. So chromium will be cathode. Correct, because reduction happens on cathode. सही है.
Yes.
And
Yes,
SOP का ज्यादा SOP. पोटेशियम का ज्यादा है, so potassium will be at anode. Correct.
Yes.
Now in cathode chromium का reduction होगा. Reduction means Cr3 positive to chromium. The potential for this is 0.74. Sorry, minus 0.74. Correct? Yes or no? Please tell me.
Yes.
ठीक है. Next is potassium, that is anode, right? So anode में क्या होता है? Oxidation or reduction? Tell me. What
Sir,
happens at anode? Sorry.
Can you repeat, sir?
What happens at anode? Oxidation or reduction?
Oxidation.
So for oxidation, what will be the reaction? Tell me. How should I write? Potassium कैसे लिखेंगे हम?
K to K plus.
Very good. K to K plus. And what will be the volt for this? For potassium?
Number 2.93 watt.
Plus or minus?
Plus.
2.93 volts. And E naught cell will be? Tell me, E naught cell will be? Add both of these things. 2.93 plus minus 0.74. So plus minus will be minus and you will get 2.19. Rabia, correct है आपका. Very good. Madiha, you got the mistake. Yes or no? Tell me, Madiha.
Yes, I got it.
Look for the rest of them. And Fahad, आपको mistake समझ में आया? Yes. ठीक है, बाकी सही है आपका. आपको बस E naught cell में mistake हो रहा है. Yes. For the last one, AG and MG के लिए 0.80 and yeah, very good, Iram. Correct. I'm going to give you guys 2 more minutes. जितना करके भेजने सकते प्लीज भेजिए. ठीक है, बट डू इट राइट है ना. थोड़ा आराम से देखिए. इतनी बार एक्सप्लेन कर दिया हमने सेम चीज को. Yes, Rabia, correct, very good. For magnesium and chromium, it is right. Slowly, you have to train your eyes in such a manner that you don't have to pick up the pen. By looking at the values of standard electrode potential, you should tell which is going to be cathode, which is going to be the anode. Okay. Sorry. So I'm writing all of these. You see, for the first one, it will be K to K positive. There is one thing, Iram. You look at the representation में थोड़ा सा mistake है, right? And chromium will be Cr3 positive to Cr. This will have an electrode potential of plus 2.19 volts. This is the standard electrode potential for the complete cell. In magnesium and chromium, obviously chromium is going to act as what? It is going to act as cathode because this value is higher. Cr and Mg is going to act as anode. And for this, it is how much? 1.99. Wait a second, guys. This will be 2.93 minus 0.74. No. 2.37. 2.37. Sorry. This is 2.37 minus 0.74. This is equal to 1.63. इधर आपका ये गलत है 1.63 गलत है otherwise it is fine. And for the last one, Ag और Mg के लिए, Ag will act as cathode and Mg is going to act as anode. And the electrode potential will be, you have to add these things now, plus 0.8. This will be 3.17. Very good, Madhiha. This is correct. 1.63 wala. And yeah, everything is correct. The representation is also right. Very good. Todd, what about you? आपने correct कर लिया सबको? समझ में आ गया आपको? Yes, sir. Yes, okay. Next, let us look at these values only and understand one more thing. अच्छा, एक चीज पहले समझ लेते हैं. When I say something has a higher reduction potential, ठीक है? Please write a note. Higher reduction potential means tendency to get reduced. Tendency to get reduced. है ना? So if you have higher reduction potential, that means it has higher tendency to get reduced and higher tendency to oxidize other. ये बात समझ में आया? If something is getting reduced, then what it is doing? It is oxidizing others. ठीक है? Please ध्यान रखिएगा. Has higher tendency to oxidize other and acts as oxidizing agent. It acts as oxidizing agent. Next is, if you have higher, rather I should say lower reduction potential means lower tendency to get oxidized and higher tendency to reduce others. Wait a second. Lower tendency to get reduced, लिखे हैं आप, not oxidized. To get reduced, and higher tendency to reduce others. ठीक है, तो खुद नहीं reduce हो रहा, वो क्या करेगा, दूसरे को reduce करेगा. Lower tendency to get reduced and higher tendency to reduce others, and acts as reducing agent. So oxidizing power की अगर हम बात करें, ठीक है, oxidizing power it is what? It is inversely proportional to the standard reduction potential. If SRP is higher, it is directly proportional to SRP. My bad, guys. Higher reduction potential means higher tendency to act as oxidizing agent. Similarly, reducing power is inversely proportional to SRP. इसको याद रखिएगा. पहले इंस्टेंस में आप लोग को थोड़ा सा काउंटर इंट्यूटिव लगेगा. It will be like reducing power तो directly proportional, but please understand it is reducing potential, है ना. If something is getting reduced, तो वो क्या कर रहा है, दूसरों को ऑक्सीडाइज कर रहा है. And oxidizing agent, it oxidizes others and itself वो क्या होता है, reduce हो जाता है. इसको याद रखिए, ज्यादा आपको फिर धीरे धीरे समझ में आ जाएगा. इसको याद रखिए आप लोग, ठीक है. Please remember this: oxidizing power is directly proportional to SRP and reducing power is inversely proportional to SRP. Done everyone? Yes or no? Please tell me. सबने लिख लिया?
Yes, sir, done.
चलिए इसमें बताइए अब आप. If I talk about most powerful oxidizing agent, कौन सा होगा? Tell me. रिलेशनशिप भी देख लीजिए. ऑक्सीडाइजिंग पावर इज डायरेक्टली प्रोपोर्शनल टू एसआरपी. तो सबसे ज्यादा रिडक्शन पोटेंशियल किसका? दैट विल बी द मोस्ट पावरफुल ऑक्सीडाइजिंग एजेंट.
Eg.
What we can write? Most powerful oxidizing agent is going to be
Ag, sir.
Ag positive. सही है? Yes or no? Please tell me.
Yes,
है ना?
yes.
Yes, sir.
And most powerful reducing agent कौन सा हो जाएगा?
Potassium.
Very good. Potassium, not potassium. K positive, rather it will be potassium, है ना? Because potassium will be giving electrons and it will be reducing others. ठीक है, ये तो आपने लिख लिया. अब हम ऑर्डर लिख लेते हैं. ऑर्डर ऑफ reducing power. देख सबसे ज्यादा reducing power किसकी है यहाँ पे? पोटेशियम की, राइट? फॉलोड बाय पोटेशियम के बाद किसका है? We have potassium followed by magnesium followed by
Chromium.
chromium and then
Hg.
Hg. Okay, and then Ag.
Ag.
Ag, right? Very good. Acha. What does this mean? It means that if we have potassium plus Mg2 positive, okay? If I have potassium plus Mg2 positive, then what can happen? 2 potassium will replace Mg and it will form 2K positive plus Mg. तो क्या कर रहा है ये? देखना आप. Potassium is reducing Mg, है ना? Mg is 2 positive and here Mg is 0. So Mg is getting reduced, and what is reducing Mg? Potassium is reducing Mg. Can you see that? Yes or no? Please tell me. Can all of you
Yes,
see
sir.
that? Okay. Next, if it is reducing magnesium, then also it can reduce what? It can reduce chromium, it can reduce mercury, and it can reduce silver. Yes or no? Please tell me. Potassium can reduce all of these things. Magnesium can reduce these. Chromium can reduce these two, and Hg can reduce only Ag. ये समझ में आया सबको? Yes or no? Please tell me.
Yes, sir. Yes, sir.
So here you have a question in CERT. And we have already answered this. Arrange these metal in their increasing order of reducing power. So the order of reducing power will be this. Okay. चलिए. Please बस इतना लिख लीजिए. Once you are done writing that, please let me know. Done everyone? Yes or no? Please tell me.
Yes, sir. Yes, sir.
So let us see if we can do some questions. तो एक नोट लिख लीजिए. There will be some questions on displacement of the salts in a particular solution. Okay. So in that case, you have to always look which is more reactive metal. ठीक है, तो more reactive metal is going to displace the less reactive metal. ठीक है, इसको important याद रखिएगा. More reactive metal कौन सा होगा? With higher SRP. With higher SRP, lower SRP. More reactive metal will replace less reactive metal in a solution. Okay. For example, if I talk about Mg and Hg, है ना? So I can say that Mg plus HgSO4 अगर हम लेंगे, then in that case, what is going to happen? Mg is going to replace Hg. You will get MgSO4, and Hg will be unreacted. Okay. So in this case, you will have reaction. But if I take Hg plus MgSO4, then it is not going to give you any reaction. This will be no reaction. Remember this. Done everyone? Yes or no? Please tell me.
Yes, sir. Yes, sir.
चलिए, moving on. Please write a reference electrode.
I can just scroll up.
Yeah, sure. We'll slightly look into the idea of reference electrode, and then we will end the class. After the class, you will have a test on electrode potential. Okay, whatever we have done today, we will have a small test on electrode potential. There will be 5 question MCQs. Okay, उसको आपको answer करना पड़ेगा. See, please see reference electrode. First of all, please don't write anything. Let us see a few cells that we have made. है ना? As for example, let me take this K positive Cr3 positive wala. See, and let me paste it here. Don't write anything now. Just listen. Now, when we have this type of cell, there will be potassium electrode, and there will be chromium electrode. They will be connected like this, and then I can put a voltmeter here. Like this, they will be connected. Okay, and please remember, only if I have 2 cells, then only we will have some kind of potential displayed. अगर हमने इसमें से किसी एक सेल को भी हटा दिया, then the potential will not be present, right? Yes or no, please tell me. No, because the cell is not completed. If the cell is not completed, voltmeter will not show anything. So we need to have what? We need to have 2 different half cells in a particular cell. In a cell, we should have 2 different half cells. Achha. If I am going to have always 2 different half cell, then I will be always getting only what? I will be only getting the EMF of the cell. And it would be impossible to determine the EMF of half cell, right? Because we need always how many? In order for the voltmeter to work, we need 2 cells. And if we are having 2 cells, it is going to give the EMF of the cell. That means the sum of both of these reactions. है ना? इस reactions कितना electricity लग रहा है, इस reaction में कितना electricity लग रहा है ना? Both of the sum we are going to get. We are never going to get the EMF of the half cell. We will never get the accurate EMF of the half cell. Now, in order to calculate the EMF of the half cell, the concept of reference electrode was used. क्या concept use किया गया? Reference electrode. Now, reference electrode का क्या काम होता है? Reference electrode का बस ये काम होता है that we have taken a few electrode और उसको हमने बोल दिया कि इसका EMF 0 होता है ना? So for example, if I take reference electrode here, then this reference electrode, it has the E naught how much, इसका SRP कितना होगा, SOP कितना होगा, all of these things will be 0 volt. That means whatever voltage is shown here, it is only due to the other half cell. Okay, कितना समझ में आया सबको? First of all, we can never determine the EMF of one half cell only. ठीक है? That is why the concept of reference electrode was used. Reference electrode has SRP that is equal to 0 volts. That is why when it is attached in a cell, the voltage displayed by the cell is only due to the other half cell. All of you understood these points? Yes or no? Please tell me. कितना समझ में आया सबको? Should I repeat?
Yes, sir.
Understood? Okay. Please write it down. Write these 2 points. Diagram बनाने की जरूरत नहीं है. अच्छा, you can make the diagram also. The potential of a single electrode cannot be determined, but the potential difference between the 2 electrodes can be accurately measured using reference electrode. An electrode is chosen as reference with respect to which all the other electrodes are valued. ठीक है, next point लिख लीजिएगा. The SRP of reference electrode is assumed to be 0. ठीक है, ये ध्यान रखो। कुछ ना कुछ तो रेफरेंस उसका, कुछ ना कुछ तो वोल्टेज होता होगा, बट जस्ट टू हैव अ पर्टिकुलर रेफरेंस, उसकी वजह से हमने उसको क्या ले लिया, 0 ले लिया। Done everyone? Yes or no, please tell me. चलिए, can I move on? लिख लिया सबने?
I already.
Yes. Right, next.
Can you scroll up?
अच्छा अच्छा अच्छा, नहीं लिखा अभी। Okay. Let me know once you're done.
Yes.
Everyone is done? Yes or no? Anyone still writing?
Yes,
Still
sir. Done.
done? Okay, very good. ठीक है. So today what we have learned, अब reference electrode के आगे हम लोग पढ़ेंगे, right? We have to read a specific reference electrode, and that is standard hydrogen electrode. So we'll understand standard hydrogen electrode in the next class. Now, let me just summarize that what we have learned in today's class. We have learned a few things. First of all, how to determination of anode and cathode, determination of what anode and cathode using standard reduction potential, है ना? Standard reduction potential से हम लोगों को क्या पता चल जाता है? We can also determine what is the anode and what is the cathode. Then next thing is that, अच्छा एक और चलिए, there is was one thing that I had to do. Reference electrode किसमें चलेगा? Please write remarks on E naught cell. ठीक है, इसको थोड़ा सा देख लीजिए आप लोग. There are a few formulas. अब उसमें से जो भी आपको अच्छा लगे आप उसको याद कर लीजिएगा. ठीक है, जो भी आपको अच्छा लगे. Now, if I look at the cases above, whatever we have used in those things, we wrote that E naught cell is equal to standard oxidation potential of anode plus the standard reduction potential of cathode. अब जो भी साइन हो उसका, एनोड में अगर पॉजिटिव है तो पॉजिटिव, अगर एसआरपी में आपके पास नेगेटिव है तो नेगेटिव. दिस इज समथिंग दैट वी हैव यूज्ड ऑलवेज, राइट? SOP of anode plus SRP of cathode, and that is equal to E naught cell. Now, if I want to write the SOP of anode in terms of SRP, ठीक है, अगर दोनों के दोनों का अगर हमको SRP में लिखना है तो क्या हो जाएगा? हम लिख सकते हैं माइनस ऑफ SOP of anode को SRP क्रम से, माइनस ऑफ SRP of anode प्लस SRP of cathode. ठीक है ना, इसी को छोटा करके ना, you will see this in many textbook, is that they would write it like this: cathode minus anode, cathode का positive minus anode. Now whenever you are seeing this, or you will see something like this, E naught of cathode minus E naught of anode. ठीक है, अब यहाँ पे E naught क्या है? This E naught is standard reduction potential, ये ध्यान रखिए. ठीक है, so एक तो ये बेसिक मेन मेथड जिससे ये फॉर्मूला आया है, एंड दिस इज इन टर्म्स ऑफ एसआरपी, जो कि टेक्स्ट बुक में आपको सबसे ज्यादा दिखेगा. ठीक है, दिस इज आल्सो अ फॉर्मूला फॉर ई नॉट सेल. डन एवरीवन? यस और नो, प्लीज टेल मी.
Yes, sir.
Okay. I can see a new student right now. Zoya, hello. Am I audible, Zoya?
Sir, it's Pfizer.
Oh, it's Faiza, but it is written Zoya. Acha, theek hai. Fine. ठीक है. All of you done yes or no, please tell me.
Yes, sir.
Now, so we were talking about what are the things that we have learned today. So determination of anode and cathode we have learned using SRP. And the next thing that we learned is that it is to calculate E naught cell. Okay. Next thing that we learned was the relationship between SRP and reducing power, and how different metals they displace the ions of different metals, displacements. So all of these things are what? These are the application of standard reduction potential or standard electrode potential or standard electrode potential. Is this clear? Yes or no? Please tell me, all of you.
Yes, sir.
Yes, sir. Clear.
Okay. Now again, I am asking few students. Let me just confirm a few things. We have Madiha. Madiha, you have your next exam on. Madiha has test on 30. April.